We're going to go to math.com, click on the algebra, let's go down to linear equations, and we're looking at 9.2. 9.2. Alright, so does this look familiar? F is equal to, and who knows what F is? Well, I don't know, maybe I'll figure that out here in a minute. 9/5 C plus 32. Whoa, what happened there? Plus 32. Okay. And we want to solve for C. I want to solve. Now there is a section, I think, a very early section in this algebra where we do things like this, but since we're talking about linear equations, solving linear equations, I don't know, I thought I would throw this stuff in here. Okay, so what do we got? We want to solve for C. Now, this particular model here models the temperature. This is Fahrenheit and how it's related to Celsius. Okay, Fahrenheit is related to Celsius. Okay. We could say F is a function of C. Well, we hadn't talked about functions yet, but anyway. Okay, so we want to solve for C. That means let's take that 32 over to the other side. F minus 32. And in some previous problems, we would get rid of this 5 by multiplying 5 all the way across. Remember that, but let's just do this. Now, of course, what we'll do now is multiply both 5/9 to both sides. 5/9. Let's put a parentheses around that. So we end up with 5/9 F minus 32 is equal to, see the 5's cancel, 9's cancel, and you're left with C. Alright, Celsius. So you want to convert Fahrenheit to Celsius. Just remember, take the Fahrenheit, subtract 32, multiply it by 5/9, if you can remember that number, 5/9. Alright. I think we'll be actually at some point in time here actually deriving the sub by knowing 2 points. Anyway. Alright, let's take a look at what else we got going on here. Let's take a look at another one. Let's take a look at another one here. I'm actually looking at my notes, seeing what I got written down. Let's take a look at, this is known as the Lenz formula. The Lenz formula. And I remember when I was first studying algebra that this kind of stuff was pretty exciting stuff here. 1 over d1 up, and I guess F is, I'm not exactly sure, frequency, focus, I don't know. I would imagine d1 is distance, and since it's a lens, and d2 is another distance. Okay, but we're just doing some algebraic manipulations here. We want to solve for F. I want to solve for F in this problem. Alright, let's solve for F. Okay, so what we're going to do here is, what am I going to do? What we could do is get this all into one fraction over here, and that means we want to get a common denominator, so I'm going to multiply d2 on the top over d2. Let's see. 1 over F. And now there's a trick that you can do here, and that is you can just flip this reciprocal, or take the reciprocal, I guess. You can flip this and then flip this one here, so we end up with F is equal to d1 times d2 over d2 plus d1, or d1 plus d2, it doesn't matter. And the reason this trick works here, this is really F over 1, is because if you took the d1, d2 and brought it up over here, took the f, brought it up over here, took the d2 plus d1 diagonally down here, we end up with the same thing. Okay, so that trick works. Alright. Anyway, there you go. Okay. There was actually a section, literal equations, where we do these kind of things, and yeah, we did a lot of that kind of stuff over here, literal equations, but we didn't really have a real application model like we do in this last one here. Alright, so we're over here at gotomath.com, which is pretty exciting because we're going to be working some actually, I think, application problems for the first time in this section until I actually add some application problems in some earlier sections. This will be the first, this next section coming up will be the first section of application problems. So we're over here at gotomath.com, and I'll see you in the next problem.